Okay, folks, let's see if we can fit a set of conic curves to an image. So let me start by first importing an image. And that can be done very simply by going over here and clicking on the plus icon. And from there, you select image, and then you navigate to the directory where you have the image, and in this case, I just double-click the image. Okay. Okay, so this image is kind of small, so what I'm going to do is I clicked on the image and then brings up an outline and a set of points. And what you can do with the points is if you can grab, let's say, on this corner and you and move it, it'll expand the image. You can also move the image by grabbing the center point, okay, and then moving it wherever you like. Now this image is, I couldn't get the camera exactly on top of it, plus the shaft inside. This is the motor from a handheld appliance, and here's a drive shaft, and that's what this is a picture of. And so what I'm going to try to do is to fit a conic curve or another to the outline of this image, okay, and it may or may not fit the entire outline, and it doesn't have to be a closed curve, which means enclosing the entire outline. It can be an open curve, which only fits part of the outline, but we'll see all of that as we get along. Here the point was import an image, size it according to whatever you want, and then you can move the image location by grabbing the center point. If you grab it somewhere else, it just moves the entire plot. It doesn't do anything else, but we may as well move the plot up a little bit right now. Okay, now that we've got that, the next thing to do is to try and find our conic curves. Now, by the way, if you click anywhere on the screen, you will deselect the image, and you can do other things now with the cursor. So let's go over to the left-hand panel. You can read all of these notes. I have programmed the conic curves in for you already. This is the equation of a parabola, and below here is the equation of an ellipse, and then the equation of a hyperbola, and then something else here which you can play around with and see what you can get. Now all of these conic curves are centered at the coordinates h and k, with the subscript simply indicating whether I'm using it in the equation for the parabola or ellipse or whatever it is. I separated out the centers because you may want to move the conic curve, two conic curves on the screen to different locations. We'll see that as we get along, but for the moment, that's all you need to know about what h and k are here. They are the center for the conic curves. Okay, so how do you get to these conic curves? You can see the equations here. Well, you turn them on simply by clicking this round button. So this is the equation for a parabola, and by clicking this button, I turn on the parabola, which is this red curve over here. I can turn that off. I can turn on an ellipse. It's a really tiny ellipse, and its eccentricity is 0 because right now it's a circle, which is not what we want, but you know that an ellipse collapses into a circle if the major and the minor axes are of the same length. Okay. And so we'll turn that off, and we will turn on the hyperbola, and there is your hyperbola. Okay, so let's go back here, and you can, by the way, change the colors for the curves by doing a long press on this button, the same button, and then it allows you to select whichever color you want from this palette here. Okay, let's turn the ellipse off. And unless you go with the hyperbola first and see if that fits, you can pick anything right now. I'm just picking it because it's the first one on the list here, that's all. Okay, so now that we've got the hyperbola, well, it's nowhere close to fitting the outline of the curve. Now, there are a couple of things that I can do. I can try and move the image by grabbing the center and moving it. Well, that's still not going to fit, but it's something that you can try as you are iterating around fitting the image and the curve. But what you can also do is there are couple of things to notice. What are called the parameters of the curve. So in this case, you can see there's x and y, which denote the variables, and then the parameters for this curve are p, the focal length of the parabola, and and h and k, which denote the center. And these can be adjusted via these sliders. So right now, p is set equal to 1. In whatever units we're using, the focal length would be 1. And let's see what happens when we move this slider. Okay, focal length decreases, it's focusing more closely. So if you had rays of light coming in, they would focus at a point which would be closer to the end of the parabola over here. And if you increase the focal length, the parabola spreads out, and any rays of light that were coming in, like vertically here, would then bounce off. If this was a mirror, would bounce off and focus at a point farther out over here. Okay, so this is better, but it's not fitting the curve. So what can we do? Again, one of the things is you can try and move the image like so, and that's one possibility. Now we're getting a pretty okay fit, but let me leave the image where it is and then show you what the impact of moving h and k is. So you can move h and k, okay? This is going to move where the x location for the center is, and as you can see, it's moving. Let's go back and leave it at 0, and let's try and move y. This will raise or lower the parabola, right? So you can do either of these things. You can lower the parabola here and then select the image again and try to move it around or something like that. Okay, now this just by chance, I picked a value for p on the slider, which is giving me a pretty good match for the lower portion of this appliance. Let's see what happens if I decrease the focal length. You can see that it's beginning to go away from, the parabola is beginning to go away from the outline of the image. I can, of course, try and adjust this by moving it a little bit, get it a little more centered. Yeah, but it's still not so good. So it looks like I need to open up the parabola a little bit. So we'll go with a little larger focal length. Okay, now this is a pretty good fit. You can see it's fitting from roughly here to about here, which is okay. What happens if we move the parabola even farther open? Well, you can see the fit starts to decrease because now there's more of a gap here, see, between the parabola and the outline of the shape. Okay, so let's go back to our slider and adjust it, and it's pretty okay, right? We can move it a little bit more and iterate around this until we get a fit to our satisfaction. Okay, so that's one. Now, okay, this is great, but this is just one of the curves that's fitting. Is there a different curve that we could make fit? Well, it would be really tough to do the hyperbola. You see, it's unless you, it's too conical here, if I may use that term. The points, the elbows, or whatever you want to call them, are too sharp for the parabola, right? So that I wouldn't try to fit that. But what about an ellipse? So let's turn on the ellipse, which is here. And as I said, right now it's in the form of the circle because the semi-major axis and the semi-minor axis are exactly the same length. And you know what happens when that length is different, right? So if you increase this, the ellipse is beginning to spread out, right? And similarly, if you do the semi-minor axis, it'll increase the size of the minor axis and begin to increase it in the vertical dimension. Which one, whether A or B controls the vertical dimension, is related to the signs up here in the equation, and you can play around with those and work that out to your own satisfaction. Okay, let's resume here now. So this was the reason I wanted to add separate centers, because if you try and move this curve to fit an ellipse to the same surface, now we have lost the match with the parabola. So I'm going to bring it back down here to roughly where it was. And the idea here is to see if the curve, if the parabola is a better fit to the outline or if the ellipse is. So we've got the ellipse. I'm going to move the center of the ellipse, which is here. So let's just move it down, k representing the y dimension. Oh, wait, yeah, okay. I just deselected it. The image automatically deselected when I clicked on the slider. So, okay, so let's bring that down. Let's bring this down to about here. And we've got, oops, yeah. An okay fit. What happens if I change the values of the semi-major and semi-minor axes? You can see there's a circle. It's fitting, but on a much smaller portion of the curve. And as I said on my note in the discussion, you can fit any curve to any other curve if there's only one point in common between them, right? Well, that's not really what you want. Okay, so let's go back here and see if we can expand this. I'm going to try and increase this. Okay, so this is a little better fit, okay? And it's fitting over a larger portion. Now, if I change the other axis, the semi-minor axis, okay, and then I can move the center again to see what I get. All right. No, this is not as good a fit because as you can see, the curve of the ellipse is deviating significantly from the curve of the object. So we'll go back to reducing the semi-minor axis and then trying to bring the ellipse back in. So here we are. We've got a pretty decent fit, but again, as you can see, if you sort of peer at it, the image is a little bit darker than I would have liked. That the parabola still fits the outline of the object till about here, right? Whereas the ellipse only does so till here, and similarly on the other side. It's not a perfect fit, but again, the idea here is to see how conic curves conform, or rather how the outlines of objects sometimes conform to the shape of the conic curves. Right. In this case, the outline doesn't follow any one curve all the way around, but there are portions of it that do match. Now, you could, of course, do something else, like if you, let's see what happens when we move the ellipse upwards. Okay, so let's take it upwards, and I'm going to do this. All right, so we move it here. What have we got here now? Okay, now let's try and increase the length of the semi-major axis, and that's actually getting to be a pretty good fit there, right there, right? So that's all you need to do. Find out, pick one side. You don't have to do both sides of, or if the object is a closed curve like this appliance over here, you don't have to fit the entire outline. You can fit a portion of the outline, but get as much of the outline as you can. And note that the different portions of the object may have an outline that conforms to different kinds of conic curves. So it's just playing around and learning about the conic curves at the same time. So you can try that. You can try fitting other curves, and as you play around with these parameters, remember the parameters are the characteristics of the conic curves, which includes the center, of course, but also things like the length of the semi-major, semi-minor axes, the distance of the directrix from the vertex, focal length, and so on and so forth. That's what I meant when I said write down the parameters. So once you've got the curve fitted, you can read the parameters right off the left-hand side panel. Include a screenshot of the curve, of the fitted curves, and include the panel in it, or you can type in the panel separately. Okay, if you have any questions, write to me, and I'll reply to you as soon as I see that message. Okay, have fun. Bye now.